Okay, in chapter 5, we're going to take a closer look at some properties of triangles, but almost always the purpose is not going to be just to memorize certain characteristics or qualities, but in order to be able to then go ahead and apply an algebra situation to it and solve for a variable or solve for parts of the triangles like we did previously. So the topic we have in the beginning here is bisectors, and there's a couple of kinds. We've seen angle bisectors before. We also are going to have perpendicular bisectors. So the perpendicular bisector sort of does three things at once. It's going to bisect the angle, it's going to bisect the segment, but it's also causing a perpendicular line connection to the segment that it's bisecting. So not only do I have two equal segments, so in an algebra equation we could set them equal to each other like we do in this example, 5x minus 6. We set that equal to 3x plus 8. We'd also be able to set these two angle measures to each other. And then the other part of the bisector theorem that we find is that if a point lives on the bisector, so for example, if I pick this point here, and it's equidistant from those other 2 points, then those two go together. So like that, if I knew that this was equidistant here, these are both 5, then I know automatically that this angle here is being bisected, okay? So in the first example here, to find the measure of xw, because these two sides are equal, 5 and 5, these two distances, yz and wz, since they're both 5, that tells me that this lives on an angle bisector. So if it does, that means that this side over here, xw that we're looking for, is going to be congruent to that 7.5 xy that we're looking for. Okay? Sort of a converse that comes away from that bisector theorem. Right? Now we go the other direction here. I can see that this is forming a perpendicular angle here. So we have a perpendicular bisector. So knowing that this is 19 and this is 19, I can automatically infer that the length of segment BF is equal to 4.2, because we have a 4.2 segment length there. So there are a couple of fancy definitions in this section, like circumcenter and incenter. We're not going to focus on those again. We want to make it our main priority just to solve for unknown variables and apply algebra if we can. So here in this situation, we can see that we're equidistant from both of these sides of these triangles, BA. This marking here shows that these two lengths are the same. AE and CE, they're equal to each other. So what can we infer from that about angle A to B to E? We know that this BE has to be an angle bisector, okay, because it's equidistant from those two segment lengths. So that means that the measure of angle A to B to E has to also be 43 degrees. They're just equal to each other. Right? And we infer that because we have those segments that are equidistant. Same thing here. If this segment's 8 and this is 8, then that means we are on a point that lives on an angle bisector. It's equidistant from those other two sides. So the measure of angle YBA, right, look where YBA is. Still noticing some folks are having trouble identifying where those angles live. But the measure of that angle YBA would be 47 degrees as well. Okay. Now notice we have this angle bisector is marked, right? It's showing me that those two angles are equal. So I can infer from that 2x plus 1 has to be equal to 3x minus 8. Now let's double back and make sure we understand what we're solving for. If we just solve for x here and move on, we're not going to be finished the problem. This is actually asking us to find mk. Okay, so I can see from the picture up here that mk is 2x plus 1. So I need to solve for x first. So when I subtract 2x from both sides here, we have 1 equals x minus 8, and then we can go ahead and add 8 to both sides. So 9 equals x. So when they ask us what's mk, we have to take that 9 and plug it back in. So mk equals 2 times 9. We just solved for x and found that it was 9. So 2 times 9 plus 1 is 18 plus 1, or 19. So mk equals 19. Okay. And then our last example, again, we can see that these two segments here are marked equal. They're congruent. So we infer from that this is an angle bisector. These two angles are equal to each other. So we can start with 7x plus 5 equals 3x plus 21. Okay? But again, let's keep in mind, what do they want? They want EWL. Well, EWL is 7x plus 5. So when I get x, I'm going to plug it back in to 7x plus 5 to solve for the measure of angle EWL. So we would subtract 3x from both sides. So 4x plus 5 equals 21. And then I'll go ahead and subtract 5 from both sides. So 4x equals 16. And then divide by 4. So again, feels like we've accomplished something here, but we're only halfway done. Remember, what they want is the measure of angle EWL. So we have to come back up here. They told us that it's 7x plus 5. Now we know what x is. It's 4. So 7 times 4 is 28. Plus 5 would be 33 degrees.